equation. So to solve a literal equation, you always do the inverse operation to get the asked variable by itself. So our goal is to isolate a variable. It's not going to be like x equals 7, like I said. It'll be x equals, boys, ax plus by or something like that. It's going to kind of go a little crazy. I'm going to come back to this blank space in a second. Let's go over to the purple page. Okay, so in every problem, it's going to tell you to solve what to solve for. So I'm going to solve for g, meaning I want g to be all by itself. So like solving an equation, I want to move over h first. How would I move over h? What would I do? Just scream it out. So, well, not scream it, but all right. So I have 5g equals 9 minus h, and then I want to divide by 5. So g equals 9 minus h over 5. We can just leave it just like that.
Can we just show all the work for that? Can we just show the final product?
I would do, since it's your notebook, I would do a lot of work right now.
Okay.
So you can go back. Some of them are going to be a lot more complex than this. All right. Okay, so here I want to solve for t. So I'm going to add r. Oh, I should have done it the other way, but that's okay. Equals 12t plus r. I'm going to subtract. I should have done it the other way. I should have moved t first, but that's okay. 8 minus 12 is? Negative, oh, not 5. Negative 4. Negative 4t equals r, and I'm going to divide by negative 4. So t is going to equal r over negative 4. For number 3, I'm going to rewrite it. It's going to make a little bit more sense when we rewrite it. So 3ax minus n all over 5 equals negative 4. Visually, it looks a little better this way. So I'm going to solve for x. So I have to get rid of this dividing by 5 first. So what do I want to do with that?
Multiply by 5.
Multiply by 5. So we're going to get 3ax minus n equals negative 20. Then I want to add n. 3ax equals negative 20 plus n. And I'm going to go over here. Divide by, 3a. And x is going to equal negative 20 plus n over 3a. There's a lot of different steps you could do, like Haley could do it a different way, Sophia. There's a lot of ways to solve these. These aren't like just my way is the only way. You could move over a different variable first. I would not divide though first, that would not work. Okay, I'm going to do that to make my notes a little make sense. All right, I want to solve for y. This is the most common one we are going to be doing over and over and over again. So I'm going to subtract 3x. So I get 5y equals negative 3x plus 12. I'm going to divide by 5. And then I have y equals negative 3x plus 12 over 5. I could also write it like this, and we'll write it like this later on. Y equals negative 3/5 x plus 12 over 5. You can write it either way. This way at the bottom is going to help us when we go to graph. Okay. This is, anybody know what we call this, Winston? What? It's not point slope form. Not the simplest form. Margaret?
I have a question about like the x. Is it in the fraction or not in the fraction?
It could be with one of the numbers in the fraction, or if negative 3/5 is your coefficient. Kind of go anywhere. Normally it's going to be your coefficient. What is it called, Rebecca?
Standard form?
Not standard form. Slope intercept form.
Yeah, I knew
So
I knew it was slope something.
point slope is y minus y1 equals m parentheses x minus x1. And we're going to get all into that fun stuff. Okay, here we are. I'm going to solve for y. This, we just have to do one thing. Y equals negative 2x minus 4. I could also write this negative 4 minus 2x. It doesn't really matter. All right. For here, we're going to subtract 2x. Subtract 2x. Negative 3y equals negative 2x plus 9. Divide by negative 3. Divide everybody by negative 3. So I get y equals 2/3 x minus 3. So the 2/3 is kind of a coefficient. You could put 2x over 3 or 2 over 3x. That would all algebraically come out to be the same problem. So it doesn't really matter. Okay. And for 7, we're going to solve for y. I'm going to add 4. So negative 6x plus 4 equals negative 2y divided by negative 2. So I'm going to get 3x minus 2 equals y. Or we can write it around. There's a lot of ways to do this. All right, we're going to try some more challenging ones. Yeah. No, you don't want to try a challenging one? Oh. The simple ones. Tomorrow you'll do the simple ones. Today we're going to work some
Are
challenges.
the hard ones going to be on the test?
Yeah,
Rebecca, is that a question?
that's totally going to be on the test.
Well,
Okay, so let's try here. We have C equals 5/9 parentheses f minus 32. And we're going to solve for f.
Oh, never mind.
No, we can't solve for C, Sophia. All right, so we need to move over. I can't add 32 and I can't move that f before I get rid of this multiplying. What's the fast way to get rid of multiplying by a fraction?
Inverse.
So we're going to multiply. Oh, Philip. Snowman took a dive. Yeah. 9/5. So I'm going to multiply by 9/5. So I'm going to get 9/5 C equals f minus 32. Now what do I want to do? I want f by itself. So what am I going to tell negative 32 to do?
Go away.
Go away by
Adding.
adding. Okay. And then we're going to try another one.
Well, this is that formula.
It is a formula. What formula is
the
it?
trapezoid one. No.
What about a trapezoid?
The area.
Area of a trapezoid. All right. Hint, hint, wink, wink, nudge, nudge.
No. See, this is on the.
I don't know.
You said wink, wink, nudge, nudge. Of course.
So,
Sorry.
yes, Winston. Okay. So I want to solve for B1. I can't move this over because that parentheses is there. So we have to move over, there's two ways we can do this. I can move over a half an h altogether, or I can get rid of the fraction, which I'm going to do first. So I'm going to multiply that by 2. So I'm going to get 2a equals h parentheses b1 plus b2. Okay. Then I'm going to divide by h. So I'm going to have 2a over h equals b1 plus b2. And now I want b1 by itself, so I'm going to subtract b2. So I've got 2a over h equals, minus b2 equals b1. Okay. I could remember multiplying by 2 is the same thing as dividing by a half. So I could have a over 1/2 h, which is still equivalent. Okay, so if you put a half in the denominator, that's still fine. Okay. All right, we're going to do one other challenging one. Oh, I can't stand. Okay, and we're going to solve by factoring. Okay? So AX equals HJ plus AK. Okay, so we need to solve by factoring. We're going to solve for A. Okay, so do you guys notice how A is hooked up to two different letters right now? So you know you're going to have to solve by factoring when your variable is hooked up to two different letters. So the first thing is I want to get my A, my same variable, to be on the same side. So I have AX minus AK equals HJ. Then from here, we factor out. What do both of these terms have? An A. So I pull out an A, leaving me with X minus K. And now A is getting multiplied by X minus K, so I'm going to divide by X minus K. So A is going to equal HJ over X minus K. And we're going to practice these in a little bit. And one other that gives a lot of people grief. Let's do M equals C over J, and I want to solve for C. Anybody think they have an idea of what we want to do first? Rebecca, what do you think?
Wouldn't you multiply the other, like the whole thing by J?
Yes, you've got to multiply by J. Why can't I multiply by C? Because I'm not being divided by C. So you have to multiply by J over here, multiply by J over here, and we get JM equals C, like that. Okay?